So welcome. This is part 4 of the video from the question number 47 onwards for the definite integrals under the concept of areas. So first of all, this question is asking, consider the function f of x equals to 1 plus e power minus 2x. Find f prime x. So the derivative is basic derivative. So it's going to be part A, f of x equals to 1 plus e power minus 2x. So what will be f prime x will be minus 2 e power minus 2x. Now I explain briefly how this shows that f of x is always a decreasing function because f prime x is always a negative. Because of this negative symbol, it is always negative. Therefore, it's a decreasing function. Let P be the point on the graph of f where x equals to negative 1 upon 2. Find an x coordinate for y coordinate of P. So y equals to 1 plus e to the power of negative 2 times negative 1 upon 2, which becomes 1 plus e. Tangent, the gradient of the tangent for the second part. So I have to find f prime of negative 1 upon 2, which is minus 2 e to the power of minus 2 times negative 1 upon 2, which is going to be minus 2e. Now we have to find in part C, find the equation of the tangent. Equation of a tangent is y minus y1 equals to m times minus 2e times x minus x1. Simplify that, you should be getting y equals to minus 2ex plus 1. Part D, sketch the graph of that one. So I am going to draw the graph. So this is the graph. Then we are supposed to draw the tangent. I am drawing the tangent over there. Tangent is being drawn. Let me draw neatly there the tangent. Now, and the value y, what is this? X equals to negative half. We have drawn the tangent. Shade the region between the curve and the tangent and the, what is this, y-axis. Find this area. So therefore this tangent, if at all I draw carefully, what is happening is this tangent is intersecting the straight line over here, the y-axis over there. So it intersects over there. Now this is the point of intersection there with the y-axis. Now I want to find it out, this red color region. This region I have to find it out. So mark this as x, y, and this is 1, and this one value is 2, and this point is P. So area will be equals to integral negative 1 upon 2 to 0, upper curve e power minus 2x minus lower curve minus 2 e power x 2x plus 1 and dx. 1 gets cancels. So negative 1 upon 2 to 0 e power negative 2x plus 2ex dx. So what does that becomes? Negative 1 upon 2 e power minus 2x plus ex square from negative 1 upon 2 to 0. Use a calculator, you should be getting this answer. Write down in 3 significant figures, 0.180. Question number 48. Let h of x is given. The curve h of x is shown below. There is a minimum point r and a maximum point s. The curve intersects the x-axis at points a, 0, 1, 0, 2, 0 and b, 0. Find the exact values of a and b. So with the GDC, a is going to be 1 minus pi and b is going to be 1 plus pi. The regions between the curves and the x-axis are shaded. Between a to 2, find an expression for finding the total area of the shaded region. So area of the shaded region, we are supposed to find it out. So it is from minus 2.14 till 1 h of x dx. Then the down area will be negative, so negative of negative will become positive. So 1 to 2 will be h of x dx. That's going to be the expression. So when you do that, you will be getting 5.141 minus of minus 0.1585. This is going to be 5.30, three significant figures. The y coordinate of r is minus 0.240. Find the y coordinate of s. Use the graphing calculator, you should be getting 0.973. Hence or otherwise find the range of values of k for which the equation has four distinct solutions. So we know this y coordinate over here and we know the y coordinate over here. Between these two, if at all, the y coordinate of s over here, if at all I draw anything between these two, you can see that I will be always getting a what is this, four coordinates. So R and S, between R and S I will be always getting it at four points of intersections. So therefore for part 2 it should be k should lie between 0.973 and minus 0.240. That should be the answer. Question number 49. The function f is defined by minus 0.5 x square plus 2x plus 2.5. Find f prime x. F prime x will be equals to x minus x plus 2. F prime 0. Plug in 0, you should be getting 2. Let n be the normal to the curve at a point where the graph intersects the y-axis. Show that the equation of the normal. So first y-intercept. Y-intercept means x equals to 0, so y equals to 2.5. Gradient of the tangent will be equals to 2, so gradient of the normal will be negative 1 upon 2. Now equation of the normal will be y minus y1 equals to minus 0.5 times x minus x1. So y equals to minus 0.5x plus 2.5. Part C, find the solutions of f of x equals to g of x. So minus 0.5 x square plus 2x plus 2.5 equals to minus 0.5x plus 2.5. This gives me x equals to 0 or x equals to 5. Hence find the coordinates of the other points of intersection and the normal and the curve. So curve and normal intersect at x equals to 0 or x equals to 5. Other point of intersection will be when x equals to 5. So y equals to minus 0.5 times 5 plus 2.5, which is going to be 0. So 5 comma 0 is going to be the other point of intersection. Let R be the region enclosed between the curve and N. Write down an expression for the region R and write down the area of the R. So area should be equals to integral 0 to 5 f of x minus g of x dx. That is 0 to 5 minus 0.5 x square plus 2x plus 2.5 minus 1 upon 2 times 5 times 2.5. This is nothing but what? Area of a triangle. What is that? This is area of the triangle. So which gives me 50 upon 3 minus 25 upon 4. So which is going to be 125 upon 12 or 10.4 in three significant figures. Question number 50. F of x is given. The paragraph of y equal to f of x, the graph of y equal to f of x is shown below. Write down the expression for the enclosed area. So it will be minus 1 and 1. So integral minus 1 to 1 e power x 1 minus x square dx. Find the y coordinates of the y-intercept. So f of 0 should be equals to 1. So p equals to 0 comma 1. Let L be the normal. Show that the equation of the normal. So f prime 0 is 1. So gradient of the tangent is 1. So gradient of the normal will be minus 1. So equation will be y minus y1 equals to m times x minus x1. So y equals to negative x plus 1. So x plus y equals to 1. Let R be the region. Then first find the point of intersections. The point of intersections are x equals to 0, x equals to 1. So 0 to 1, e power x, 1 minus x square, minus of 1 minus x dx. So simplify that by the calculator. You should be getting that answer as 0.5. Question number 51. Sketch the graph y equal to f of x. So the graph more or looks like this from the graphing calculator. This is R, this value is Q, and this value is P and 1. 1, 2, and 3, x-axis, y-axis, and 0. Show that f prime x equals to this much. So I'm using product rule. So f prime x should be equals to 2 e power minus x plus 2x plus 1 times e power minus x, which is going to be 1 minus 2x times e power minus x. Find the exact coordinate of q. At q, because it is the maximum point, first derivative should be equals to 0. So 1 minus 2x equals to 0. So x equals to 1 upon 2. So y value will be 2 e to the power of 0.5. So what will be the coordinate of q? 0.5 comma 2 e power minus 5. Part C. Find f of x equals to k has two solutions. Two solutions means we can clearly see that it should be between 1 and q. So k should be lying between 1 and what is this? 2 e power minus 0.5. Let R be the point on the curve with x coordinate equal to 3. Find the area enclosed by the region between P and R. Between the curve and the line PR. So first of all, we have to find the line equation of the line PR. So gradient of PR equals to, so first of all at R point, at R y equals to 7 e to the power of minus 3. So gradient of PR equals to 7 e to the power of minus 3 minus 1 by 3. Now that is gradient of PR. So equation of PR, y minus y1, y minus y1 equals to, which is nothing but what, 7 e to the power of minus 3. What is P and R? PR gradient, we got it out. We will try to do in this. So y equals to mx plus c. So y is m is e to the power of minus 3 minus 1 upon 3 times x plus c value is 1. This is the easiest way to get the equation of the straight line. Now the shaded area will be, I want shaded area which will be integral 0 to 3 upper curve minus lower curve 7 e to the power of minus 3 minus 1 by 3 x plus 1 and whole dx. Simplify by calculator, you should be getting 0.529. Question number 52. F of x is given, g of x is given. On the same diagram, sketch the graphs of f of x and g of x. From GDC, you should be able to approximately get this as a shape. This is f and this is g, x, y, and 0. Consider the graph of f. Write down the x-intercept at x equals to 0 and at x equals to 3. So x-intercept is going to be 2, 0. What is the period? Period for f of x is 2 pi by 1 by 4, pi by 4, which is going to be 8. That's going to be the period. 2 pi by this number, pi by 4, which is 8. Amplitude. The front number is that is the amplitude, so amplitude is 5. Next, consider graph G. Write down the two x-intercepts, the equation of the axis of symmetry. So 2, 0, 8, 0 are the two intercepts. Axis of symmetry is exactly in middle, x equals to 5. Let R be the region enclosed between the graphs. Find the area of the R. So find the points of intersection will be 6.79 and 2. So it will be minus 0.5. See the brackets, how am I using? Plus 5x minus 8. Then minus 5 cos pi by 4 x. Then dx. So simplify this. You should be able to get that answer as 27.6. Question number 53. H of x is given. Sketch the graph between minus 3 to 7 and 2 to minus 2 to 8, including the asymptotes. So this one is without GDC. So my vertical asymptote is x equals to 2. This gives me the vertical asymptote, and 3 divided by 1, 3 from here, 1 from here, 3 divided by 1 equals to 3. That will become the horizontal asymptote, y equals to 3. Then approximate shape of the graph will be in this way. Write down the equations of the asymptotes. So vertical asymptote is x equals to 2, horizontal asymptote is y equals to 3. The expression can also be written as 3 plus 1 upon x plus 2. Use this to find the integral. So integral of h of x dx will be 3x plus ln of x minus 2 from 3 to 5. So it becomes 15 plus ln 3 minus 9 plus ln 1. So which is going to be 6 plus ln 3. On the region, sketch the region area between 3 to 5. Between 3 to 5. 3 and 5. This is going to be the area between 3 to 5. Question number 54. Let f of x is given. The region R enclosed by x-axis is also given. Find the region R. So limits are 0 to 5. 0 to 5 f of x dx. Use the calculator. You should be able to get 52.1. Then the diagram 2 shows 0 to 5. The diagram 2 shows a part of a graph of quadratic x times a minus x. The graph G crosses x-axis at x-axis when a. The area of the shaded region is equal to the area of the R. Find the value of a. So integral 0 to a x times of a minus x dx equals to 52.1. So which is ax square upon 2 minus x cube upon 3 from 0 to a equals to 52.1. So a cube by 2 minus a cube by 3 equals to 52.1. From here a cube equals to 6 times 52.1, which is going to be 6.71. So a equals to 6.71. Question number 55. Let f of x is given. The graph f is shown. Show that f of minus x is equal to f of x. So f of negative x equals to a times negative x upon negative x whole square plus 1, which is negative ax upon x square plus 1, which is negative f of x. Given that f double prime is given, find all the coordinates of points of inflection. For points of inflection, second derivative should be equals to 0. 2ax times x square minus 3 should be equals to 0. X equals to 0 or x square equals to 3. So it becomes 0 comma 0. If it is plus root 3, it becomes a root 3 by 4, or else if it is minus root 3, it becomes minus a root 3 upon 4. It is given that integral is this, find the area of the shaded region from 3 to 7. So the parts are a upon 2 ln of x square plus 1 from 3 to 7. So a upon 2 ln 50 minus ln 10. So which is a upon 2 ln 5. Find the area 2 to 8 f of x minus 1. So 2 to a f of x minus 1 dx from 4 to 8. So what's happening is I'm shifting the limits by 1 unit, so the area will continue to remain as a upon 2 ln 5, but this 2 is there, so therefore it's get multiplied with 2, so then 2 gets cancelled, so area will be a ln 5. That completes part 4. See you in the part 5. Bye.